before we get started, here's a cool example that uses shape keys, but it uses drivers to drive them, just to show you just how powerful they can be. So we have a little setup here in a separate layer that allows you to control the character's face just by grabbing these along usually X and Y values. So for example, if I grab the brows, you can see the brows move in various ways, from surprised to kind of sad looking, and we could move it there, and then we can change the look, and that changes where he's gonna look, so we can precisely position it where we want it, or we can just make him look retarded. It's a little bit touchy. The drivers aren't set up perfectly, but you can get to a point we can have them just kind of looking around like that. And then we have stuff like the mouth movement, so we can make his mouth do all sorts of interesting poses. There's movements for pucker. You can make him do a little pucker. Again, these are very finicky, but I'm just showing a very quick example. You have upper lip control. It's not going to show up right now, though. I don't believe bottom lip will either. Oh yeah, you can make his bottom lip open more when he's doing that. Can you still move the mouth now? I don't believe. Oh yeah, a little bit. There you go. And these can all be animated. You have full jaw movement, so you can give him, hey there. And yeah, there's all sorts of interesting things to play with. So yeah, that's just an example of how powerful drivers can be, especially when combined with other things like constraints and with shape keys and such. So anyways, let's get into the lesson. Hey guys and gals, and welcome to another video from the team here at BlenderTech.com. If you enjoy it or learn something from the video, consider liking it and consider subscribing for more Blender, Unity 3D coding, and all sorts of other CG related videos. Lastly, don't forget our motto, create your way. So lately, all my time has been spent in working on my submarine simulator game. I've got the water down, the UI, and some of the other scripting. So it looks pretty and some of the scripting works, but as you can see, I need to work on the physics. They're not perfect yet, and I just got a placeholder model. But anyways, what I wanted to talk about today was drivers in Blender, because it seems that everybody that learns Blender wants to create rigs for some reason, whether it be character rigs, whether it be mechanical rigs, or whatever kind of rig. And whether they use armatures or object constraints or drivers, it doesn't really matter. They can all achieve the same thing, really. Now, when I did my recent video on doing the constraints in our intermediate rigging series that I've started, I thought about, hey, drivers can achieve the exact same thing, so why don't I try to show you guys how drivers work? Because I know for the longest time when I was learning Blender, I had no idea what drivers did. I had no idea what they were, what they did, and what they affected, how they worked, how to use them. I had no idea for the longest time. When this occurred to me, I thought of the fact of when you right click on something, you get this, maybe that's not a good example, whereas one like this, you get this copy data path. And now you may have tried before to say copy something like that and try to paste it somewhere else, but you realize there's no paste, and you say, well, what is this copy data path there for? And I know that when I was new to Blender, I was trying to copy and paste values and realized that it didn't work that way. So I asked myself for the longest time, what does this copy data path mean? And so the tooltip really gave me no ideas, but that's going to be a very important part of our lesson, is this copy data path. So anyways, let's get started on a basic lesson about how drivers work in Blender. So what I've done here is put in about 2 minutes at modeling my very quick version of a piston and a connecting rod. So the connecting rod is going to be named Cube just for ease of use and because of its general shape, and the same for the piston, because its general shape is a cylinder, we're going to call it cylinder. Now if I scroll up to the top of the end panel here, in fact any value really, you may have come across this before where you've accidentally had something turn purple because you've pressed the button D when your button was hovering over it. And it could be, it can be any value. So it could have been, say you were adjusting your camera, say you were adjusting the focal length between say 16 and 32 millimeters, and you might have pressed D or something and it turned purple. So that means that a driver is affecting those values. But what does that mean exactly? Well, let's start with the basics. Now, what our objective is going to be to have the connecting rod affect the piston in some way. Now again, we could do this through constraints, just like I did in my constraints video, or we could do some sort of copy location or rotation, or we could do a transformation, which I haven't gotten into yet in videos, but I kind of showed a teaser to, and this would be a good way to do it. You could do it straight through an armature probably, or an armature with some constraints, but you can also do it with drivers. But when you go over a value and you press D to insert driver values, which by the way you can just right click and hit add drivers, or if you just want to add a driver to a single value, you just decide which value, say it's Y in the Y rotation. I would just right click and go add single driver, and you'll see just that one turns purple. Where exactly do these work? You can see cylinder, our piston, now has this squiggly line, which would indicate an animation usually, but this means driver in this case. You will find this in the graph editor under drivers. So you'll see drivers, we have a Y Euler rotation under cylinder. The object cylinder has a driver, and the driver happens to be a Y Euler rotation. And if we zoom in here, we can sort of tell, but this is basically your X is your input value and your Y is your output value. So right now it has got an input of 0 and an output of 0. And if we go back to the 3D viewport, obviously it has it's 0 all the way through. Now before I get into how to actually use drivers, let's I'm gonna get rid of that one. Let's go into the user preferences first. Now what I do when I for any beginner Blender users, and even myself, so it doesn't clutter things up, I suggest the first thing you always do is you uncheck the Python Tooltips option in your user preferences, because if I just enable it quickly, and we're going to do this, you'll see now whenever I hover over something, you get that you could call it a line of code almost. In this case, it's bpy.data.objects, square brackets, and a string cylinder, dot scale. So which basically means Blender Python, a data block of type objects. And the object is a cylinder in a string, if you know what a string is, if you've ever coded, and it's in this case we're affecting the scale of the object cylinder. So that's what those things mean, is they're Python, they're bits of Python code that you can use to affect the value that that you're hovering over. And again, we can do any value. I could this priority here, I can add a driver to that. Of course you can animate values too, but we can use drivers on them just the same. Ambient occlusion distance, I can work with that, because you can see it has a bpy.dataWorld, world.light settings.distance. And we're going to get into this in a little bit later part of the video. So I want to just make sure that before we get started, for the first time ever, or if you haven't checked it off anyways, make sure, or if you do have it checked off anyways, make sure that you have Python Tooltips enabled for this lesson, because it's gonna definitely come into play. So what exactly are drivers? If we hop on the internet and look up the actual definition under the wiki, we get drivers can use properties, numbers, transformations, and scripts to control the value of properties. So that might not make a lot of sense at first, but it will very quickly once we get to the actual visual part of it. But the interesting part about that is we can use scripts to control the value of properties. Now you may say, well, I'm not a programmer. I've never scripted in Python before. That's okay. That's why these tooltips are important. So let's get started with some basic drivers, however. So in this case, let's affect our Z location of our cylinder, of our piston, so that it will go up and down. Essentially, it's going to be our goal. So let's add a driver to the Z location. So I'm just going to hover over it, right click, add single driver. Now you can split your windows however you like. I mean, sometimes I like to use the graph editor like this, but it can get a little confusing that way. And sometimes I like to use my graph editor like this. So it really depends on your preference. I do this when it gets to be higher numbers, but I find that can be a little bit distracting sometimes, and I'm used to splitting my window this way for node editors. So in this instance, I'm going to split my window horizontally and have the graph editor in here. So we can see we've added a driver on our cylinder for the Z location, and its current Z location in space is 0. So what that means is on our frame, which is frame 1 right here, it has a value of 0 right there. You'll see if I move along, if I grab my cylinder along the Z axis, you'll see it doesn't change. It's trying to change in the UI down here, you can see, but it's not changing at all. Why is that? That's because we have a driver controlling it now, so we can't manually control it. We can, however, grab the dot down here for its value, and we can grab it along the Y value, which would be the output, and we can thusly move it. So you can see if I want to move it 1 unit up, I go to the 1 mark, somewhere around there. I'm not gonna, well, I can just type in Y1. So now our Y is at 1 when our X is at 0. So our input is still 0, but we've got a result of 1, an output of 1. So now it's moved to 1. Now that may seem very unuseful. Yes, we could do that by hand. We could just move our piston, our cylinder up by 1 unit, but this is obviously not the full scope of drivers at all. We're going to use another object to control it. In this case, our connecting rod, our cube, which in this case has no drivers connected to it. Before we get into that though, in our graph editor, with making sure we're in drivers mode, with our piston, our cylinder selected, let's open up the end panel or the properties panel so that we get this view, because this is where you're going to be doing basically everything that has to do with drivers. You can see everything that has to do with drivers here, and you may have seen this before, and it may not make any sense to you, and you may have seen under, say, like the object data tab, custom properties, and you may have wondered, well, what the heck does that do? We're going to get into that as well. So make sure you have your graph editor open under drivers view. Make sure you have the properties panel, the end panel open, and it helps to have the end panel open, or wherever your driver is, the purple one, make sure that's in view, and it's nice to have the object in view too, so we can see what's going to happen to it. Currently, our driver has a scripted expression with an expression of 0. So it basically does nothing. And it's giving us an error. Python auto execution disabled. And it says up here auto run disabled. So what that means is, because we're technically kind of scripting in this way, what we want to do is go into our settings, user preferences, go over to file, and then check off auto run Python scripts and just save it. This can be a problem if you download something and it's untrusted. People could technically do something bad with some Python scripts, but it's most of the time nothing to worry about. However, if you are a security freak, definitely have that disabled whenever you don't need it. But now you'll see that our error has gone away, and we can now ignore the auto run disabled error, and we're back to a completely usable scene. So what exactly does the scripted expression mean? Well, before I get into that, let's click on this and see the different kinds we have. We have maximum value, minimum value, we have scripted expression, which we're in, we have sum values, and a range value, or average value, ranged. And checking this off, you'll see it gives us, or if we select some different ones, you'll see we get errors, invalid target channels. Basically, that's saying that, okay, we're not getting any information, so it's not going to do anything. So we'll start with scripted expression. What scripted expression does basically is it allows you to do math. For example, if I put an expression of 1 in, it's simply going to move it up 1 unit. We could do all sorts of other math too. We could go 1 divided by 2, so it'll move it up 0.5, and you'll see it changing here. So my input is 0.5. You'll see it's 1 is right about here, so I'm halfway is my input, so 0.5 is my input, and if I go up here, my output is 0.5. So they're equal, but this just shows you how the input goes into and works with the output. So if I added something like 3 times 2 less 6 divided by 2, enter, well, that still gives us a value of 6. So our input is 6 because that's what this math equation equals out to, and it gives us an output of 6. Now again, that may seem useless. You can say, well, I can just move it up 6 units manually. Why are we doing it this way? Again, it will become clear very soon. To make that a little more apparent, you'll notice we have variables down here, and by stock, whenever you add a driver, Blender add one's called var, which stands for variable. So we'll just leave it set as var for right now. So right now you'll see it's all in red, so that means nothing's set up, and we have a bunch of options. Transform channel, which basically means, you know, we can choose the usual ones: scale, rotation, location. We have single property, which we'll get into. We have a rotational difference, you know, which would be like the difference in rotation between one object and another. You have distance, which would be the distance between one object and another. So there's a lot of flexibility in this, but let's stick with the transform channel for now. So we're going to choose our object, which is going to be our connecting rod, obviously, since it's our only other object in the scene that we're going to use, which happens to be the cube. And we're going to choose, how about its Y location in world space. So that is our variable. So variable right now stands for the cube's Y location in world space. And you'll see right now its value is 0 because in world space, right now our cube, our connecting rod, has a Y value of 0, as you can see right here. If we change it to 1.123 and then go back, you'll see now it has a value of 1.123. So maybe this is starting to make sense. I'm going to undo that, however. So how this works is we can now use these variables that represent other objects in our scripted expression. So let's put this back to 0. We'll get it back to our original scene. Let's do something like var. So that takes whatever value which that var stands for, which is in this case the Y location of the connecting rod. Let's just set it as var. So let's see what happens now when we move our connecting rod along the Y. So I'm going to grab it along the Y. Notice how it moves right along with it. So that's starting to get into some cool parts about drivers. But again, we could do this with constraints and such, but I find that this is easier sometimes, especially if you have coding experience. But you don't need coding experience, and it helps to have a little bit of math skills, but again, you don't need to be a master mathematician to be able to figure this stuff out. Now, to make this look more like an engine, we could also choose, say, Z location, and we would get when we grab it, no matter where it is. You can see I can move it all along the Y, but it's going to follow its Z location no matter where it is. But that's a little boring. Let's say we wanted twice what its value is. So all we do is we go var times 2. So now for every unit we move this up, it's going to move the piston up 2 units. So if I grab it, you'll see it's moving up a lot more. So you can see how this could be used for some sort of engine, which is kind of what I wanted to illustrate. It can be used for characters, of course, and any other kind of transformations and constraints and whatever you might want to do. Drivers are used all the time for that, but I mostly do mechanical models, so that's what I usually default to. But anyways, let's get rid of that. Let's get into a little more advanced, stuff here. Let's add some more things, because this is pretty boring right now. We could achieve this in quite a few different ways. Let's, for example, play with our curve. So we have a regular curve here, which is just like any other curve that you would play with in Blender. Let's grab a couple of the points and just move them to see what happens. So I'm just going to throw this one over here. I'm going to move this one over here. So we no longer have a perfectly straight line. Let's see how that affects our little scripted movement here. So now when I grab it along the X, you'll see it's kind of making weird motions. It goes, when it gets to the negative numbers, it goes down really slowly. But when we get up to the positives, right when we go above 0, it really gains speed. So our curve is no longer linear. And you can adjust curves obviously however you want. You can have this curve in any shape you want. We could have it like that, and we could have it like this. We could duplicate points on the curve to get like really funky curves. We could rotate it, so you can see we have this really funky looking curve. Let's see how that affects it. So now when I grab it along the Z, again you'll see now it's really playing with us. So you can see through editing the graph, you can get some very interesting motions created. See how it's jumping and creating all sorts of weird motions whenever I move it along the Z axis. Now obviously that's not perfectly usable right there, but it just shows how editing the graph can be useful in its own right. But let's get into the actual driver aspect more. Editing curves is used in other parts of Blender, and it doesn't need to be a full lesson in its own right here. So I'm just going to put it back to its straight line, which I believe was like that. So we're back to where we were. Let's quickly show you how you can add more variables in. So let's just create another object. I'm just going to add in a mesh. We'll just do a circle for fun. And I'm just going to grab it along the Y just so it's out of the way. And I'm going to rotate it so we can actually see it. Alright, so we now have 3 objects. A circle, our cube, and our cylinder. So let's add another variable in. So we'll just hit add variable. And let's name this one circle. It's good to have a good nomenclature as always. I mean, we could obviously call this one cube. Now that would obviously make it so that our expression wouldn't work anymore. So we would have to change var to cube. But it's always good to have a good nomenclature that makes sense to you so that you know how things work. But yeah, we're going to use circle. So let's use the circles. We'll go into the transform channel again. We'll choose our circle. And let's just leave it on the stock X location. So let's try something else now. Let's go cube times circle. So that'll take the cube's value in the Z location plus the circle's value in the X location and output it to our driver value, which happens to be our cylinder's Z value. So now, as before, we can move our cube, our connecting rod, but it doesn't seem to be doing anything. Why is that? Well, let's try moving our circle. Again, nothing's happening. But if we go to our cylinder, you'll see nothing is happening. Why is that? Well, that's because our circle is only moving in the Z and Y axis right now. You'll see its value is 0, whereas cube is -5.5. So let me undo all that. And let's work in 3D space now. So now if I grab the circle along the X and grab this along the Y, or sorry, along the Z, now you'll see something starts to happen. Now I can leave it there, and I can grab the circle along the X, and you'll see how they both affect them. And so we could obviously animate these to both affect them. And I have to do these separately right now, but so yeah, now we've got a value of -1.9 for the circle, -1.1 for the cube, and it gives us an overall value of 2.15 because a negative number times a negative number is a positive, so we have a multiplication here. So that just gives you an example of how to add variables. So we'll go back into orthographic view. What else can we do with drivers? Again, this is still very simple. You may be saying, well, it doesn't look too useful to me. It's kind of neat. Okay, I understand how drivers work in the most basic form, but where are they really useful? What are the cool things I can do with them? Well, one cool thing is you can add modifiers. Now, you may have used curve modifiers before in the curve editor. So let me show you how this works. We'll stick here. We'll leave our circle, but let's get rid of the circle variable, and you'll see we now have an error, invalid Python expression. That's because circle no longer exists as a variable. So let's just keep it as cube. So that way the Z location of the cube affects the Z location of the cylinder. Actually, let's just go cube -1. We can add a modifier now, so let's add a noise modifier because I find that makes the most difference. You'll see if I turn up the strength, it's really affecting our curve. So now when I grab our cube along the Z, I guess I have to zoom out maybe, and let's just go full screen. You'll see now it's creating all sorts of weird motions. And that's not very useful, obviously, in its own right. But again, it just goes to show that you can add modifiers. So there's all sorts of modifiers. You can add noise, you can add cycles. So you can see now it'll work like a phase. So this could be used for an engine too. So I grab along the Z, you can see how no matter where I move it, it's always going to go up and then down, up and then down, up and then down, even in negative numbers. So you can see how it's moving like an engine now. So we could have a slider that we could have animating that would make something move up and down for some reason if we wanted that. And you'll see the values that it will change here. So you'll see it's going to move a maximum of 1 unit up from 0. So you'll see it starts off at 0, it moves up to 1, goes back to 0, moves up to 1, back to 0, and so on and so forth. And of course we can adjust this curve, or we can add more modifiers, and there's all sorts of other options. And yeah, there's some other neat modifiers. The generator, for example, allows us to do more math. You may remember how polynomials work from high school pre-calculus. Let's not use so much math though, because obviously no one likes math. You can look up more on the different modifiers and how they work. I just wanted to stick with the basics. Let's work with the other types of drivers here. So no more scripted expressions. Let's add our variable back for our circle. So I'm going to call it circle again. And we're going to do a transform channel. We're going to do just like before, the X location. So we have our same values, our same output. And at any time, if it doesn't change, you can always hit update dependencies, and that'll make any change apparent if it doesn't update automatically. If you're doing an animation though, it updates on every frame regardless, so you don't have to worry about that. But anyways, so let's go cube minus circle. You'll see it updated for us, but it's an invalid Python expression. Well, that's because we happen to have a driver value of 0. Or actually, Python's context sensitive. Just wanted to show that off to you guys. So make sure when you name your variables to remember that Python is context sensitive in most, if not all, instances that I've run into. So we have cube minus circle now. So as always, we can move these to get our different properties. Oops, I have to work in 3D space for this. And each one affects it a little bit differently. If I grab them both, you can see they both affect it differently. But anyways, let's undo those movements. Go back to where we were. So yeah, I'm going to show off, we're going to get rid of scripted expression. Let's start with some values. So now what this does is it adds up all our variables essentially. So it adds up the cube and it adds up the circle. So in this case we have negative 1.12 plus negative 1.9. So if we calculate negative 1.126 plus negative 1.910, we get obviously the same number. Well, it rounded up a little bit, so obviously there's a little bit of difference in there, but you can see how that works. So it just adds the values. And again, if we grab this, it works. It just now adds the values. I'll grab them both at the same time. It just adds the values now. And everything else works exactly the same way. Average values averages them out. So if we calculate, we get the same number. So 3.036 divided by 2. There you go, you get that number. So it averages all your variables out to get your output number. And you'll see our output number right here of negative 1.518 is right here, negative 1.518. And so minimum value, it will choose the least value or the lowest value out of all your objects. So in this instance, it is the circle, so it chooses that. But if I move the this one down lower, you'll see it doesn't move, it doesn't move, it doesn't move until it reaches that further point, and then it starts to move. So you'll see now it's decided to choose the cube's value instead, since it's the minimum value in this case. And it works the same way for maximum value. In this case, it's going to use the cube's value because it's the maximum. It's the higher value in this case. So obviously, I'm not going to show that again, but you get the idea. Now we don't have to be stuck with just these. We can do this through scripted expression. If you search online for scripted expression driver. You could say driver, yeah, just scripted expression drivers in Blender. You'll get a list of all sorts of operators you can use. So I can go min, and then in brackets I'll just put cube, sorry, context sensitive cube, comma circle, and so it does the exact same thing. The minimum is obviously the circle, so it chooses that's value, but you can do the same thing through scripted expression. You could do, however, min plus 1, and you get that number. It obviously adds 1. So you can see how this can get more and more and more complicated, and your objects can really become very quite it's like a completely flexible constraint system. Basically, you can set up any constraint that your mind can come up with, as long as you can figure out the math in some way. But before I get too long into this video, let me bring up the Python tooltips that I introduced at the beginning. So in this case, I'm going to bring up, let's find something to pick, and we'll get the custom properties last. Let's find a value, just one that would make no sense. Ooh, excuse me, otherwise. Maybe sampling is a good value because my preview and render values are 10. So you'll see we have bpy.data.scenes brackets string scene dot cycles dot samples, and so that output would be 10. So what happens? What can we do with this? Well, let's right click and copy data path. And now you'll know how this is finally used. So for our scripted expression, let's use that. So I'm going to paste it in there. Cycles.samples. Invalid Python expression. Let's get rid of our variables. So cycles.samples in itself doesn't work in scripted expression. You'll see we get a value of 0. However, So we can't just copy and paste this data path into there. It gives us an invalid Python expression. Why is that? Well, let's add a new variable. We'll leave it called var, and we want a single property. So if you click this box here, interesting. We have all these different things that we can get data from. So we're trying to get data from the scene. How do I know that? Well, when I hover over the render, we see it's bpy.data.scenes. So that's Blender Python, which you can ignore. So .data, so we're getting data. .scenes, so it's scene data. So I'm going to select scene, so I'm getting scene data. And so after that, what scene are we getting it from? Well, that's the one in the square brackets. That's a string in quotation marks. So it's scene. If we had multiple scenes, it could be scene 1, it could be whatever you named it. But in this case, it's named scene. So under this one, I'll select scene. Now it asks us for a path. So this is where this comes into effect. So the path is the .cycles.sample. So now I can paste it in there. And if I hit enter, we now get the value of 10. However, our cycles.samples as our scripted expression doesn't work. So let's get rid of that. Instead, let's replace it with var and hit enter. You'll now see we have a value of 10. You'll see it move 10 units up. So what it's doing is it's using the render samples as an input for its Z location. Again, why would you want to do that? I don't know, but it just shows you the power of this. And if we change the render samples and then update them, you'll see 112. So now it's way up high, 112 units up high. So yeah, that shows you a little bit of power there. Let's get rid of that one though. Let's not use scene samples because that makes no sense at all. Let's do this as if we were just starting out again and we had no idea what this was doing and we're just playing around with it. So I'm gonna take, well, none of these are making a lot of sense to me, but well, let's see here. No, nothing really. Why would I want to get data from any of these? Well, let's choose object. We know what an object is. An object is obviously anything in our outliner panel here. So what do we have here? Well, we have all our objects. I've seen something like this before. Let's choose our circle instead. And again, it asks for a path. So let's go to our circle. Let's go to the object data and we'll use a standard one. Again, say the scale in this instance. So we want, let's say, the X scale. So you can see it's Blender Python.data.objects square brackets string circle dot scale. But you see it's the same for X, Y, and Z. Well, let me show you why that is. So let's copy the data path. Let's go back to our cylinder and let's paste it into the circle. Scale. Nothing happens. That's because we want the scale of a certain one. So if we put in square brackets 0, it gets the value of 1. Why is that? Well, let me change it to 1 and maybe it'll make sense. Well, we still get 1. Let me change it to 2. We still get 1. Let's update. Nope, still got 1. Let's change it to 3. Get 0. So why is this? Well, the way this is happening is because scale by itself has no value, but when you add in the square brackets, now it's getting a value. So in this instance, you would start at 0. If you know computer programming, any series, any array of data starts at 0. So the first value is 0, the next one is 1, the second one, or sorry, the first one is 0, the second one is 1, the third one is 2, the fourth one is 3, and so on. So scale 0 is effectively getting the first data point, which is X. So it's a scale of X. So let's see how that plays out. So right now, the scale of 0, which is X in this case, of our circle, you can see it's 1, is going to affect, again, still the Z direction, the Z location of our of our cylinder. So let's change let's grab the circle and see what happens. So if I grab it along the Y, no change. If I grab it along the Z, no change. But if I grab it along the X, no change. Why is that? No change at all. We see we are getting a value of 1, and we're getting a driver value of 1 no matter where we move it. Why is that? Well, because we have to scale it. So now that we have this set up, the scale in the X direction, so scale 0, which happens to be which happens to refer to X, is going to affect the Z location of our cylinder, because we've set var, which takes that in there, which is driving the Z location of the cylinder. So now if we scale this along the Y, nothing happens. If we scale along the Z, now we're getting something. If we scale along the X, well, you can't scale that along the X, I guess. But if we scale along the Z, notice how it's moving with it. So if we scale it, it moves it with it. So the scale of the circle is affecting the location of the cylinder. So to illustrate this a little bit better, I've taken the scale of the circle, and the X is 2, the Y is 5, and the Z is 12. So let's just illustrate this quickly so that I can try to make this a little more sense. So if we scale 0, we get a value of 2, which was the X value in the circle scale. So if we go scale 1, we get 5, which was the Y value. And if we choose scale 2, we get 12, which was the Z value. And if we go scale 3, we get an error because there is no third value, or in this case it would be a fourth. There is no fourth value in this data array. This can work for anything too. We can go location 0, and that gives us the location of X, which happens to be -1.9. So you can see -1.9. So that's pretty confusing and not the best way to explain how to get data path information from objects and things around your scene. But this is my first time recording. I didn't practice it because, well, a few reasons this morning. I didn't practice this tutorial, but hopefully you learned something from all of this. However, let's get into custom properties. That gets a little interesting. So for our circle, actually let's choose our cube. Let's get rid of the circle. Let's forget about it for now. For our cube, let's add a custom property. So just hit add. We're under the objects tab in the cube. Let's hit add. So it will add a value called prop, and it has a slider which we can change from 0 all the way to 1, and we can hit edit, and it allows it to edit everything. So let's just call this my custom property. You can see prop stands for property, but property value starts at 0, minimum is 0, maximum is 1. Let's change it. Minimum is -1, maximum is 1. And under tooltip, we'll say this is a custom tooltip. So if we hit OK, we now have my custom property, and we can go from -1 to +1. But by stock, it's set to 0. And if we hover over it, it says this is a custom tooltip. So this allows you to leave custom properties, and you can leave a little note to yourself when you hover over it to say exactly what this does. So if this was, say, I don't know, this does that is what our property is called. You can say this property scales the cylinder along its x-axis, for just an example. And then you could say, oh yeah, okay, I remember that does now. The more I increase this, the more it scales it along its x-axis. But let's edit this, and I'm just going to call this property custom, and the tooltip doesn't matter. We'll just say custom tooltip. so that you don't get confused. But its min and max value is -1 and 1. So let's select our cylinder again, our piston here, and let's get rid of this one. So we get an invalid Python expression because the var doesn't exist anymore. So let's get rid of var, but let's add a variable. How do we get our custom properties? Is what I'm trying to get to. So let's add another variable. We'll just call this one my new property, or my new prop. I'll go property. We want a single property. The property type is going to be of an object. The object is going to be of our cube because that's what we placed it on. And the path, well, I just remember what I called it. It was custom property, I believe, or our custom property. You'll see it's not red, so that means that works. So custom property. So now if we enter in my new property, again, case sensitive, our variable name, that goes red. So that obviously wasn't the name yet. Let's go back to our cube and see exactly what it was. Property custom was the name. All right, let's change that. Property custom. Nope, still no good. That's because of a very important thing I want to point out. If we go back to our cube and our custom property, you'll see in the Python tooltip, it's Blender python.data.objects cube. Okay, we've got that set up, no problem. But it's dot and square brackets and in quotations property custom. So that's the value we need. So I want to explain why you can't just type this in. So what we need to do is we need to put it in brackets. Still doesn't work. We need to put it in square brackets. And I'm not going to go through I'm not going to go through how to script in Python 101, but you can see that's how you use your custom property. But you'll see its value is now 0. But if we go to cube now and change it, notice how we can now have a slider that affects the X and Y value of our cylinder, our piston, from -1 to +1. Kind of cool. So you can add your own custom properties that you can adjust at any time from within the properties panel to affect other objects or other properties or other data blocks. You can basically do anything. So we could do something like my new property +1 is obviously going to add 1 to it. So now when we go back to our slider for cube, if we go all the way up to 1, it's going to be 2 units up. So we have 2 there. And if we go down to -1, it's going to be at 0 because -1 + 1 as we set it up here. But you can add property plus another property. So you can obviously get very complex things here. And this is a perfect example where we go to our cube, which has the custom property, right click, copy data path, go back to our driver setup, and in this case we can paste it in and it will give us the exact formatting, if you will, that we need. So that is all the basics of drivers that I can think of. It went on a lot longer than I intended, but I hope that you learned a lot from this and you now understand how drivers work in their most basic form. So yeah, in conclusion, very basically, it works on a curve system. It works on an input and output system. It works through scripting and variables. You can add custom properties. You can get any value from absolutely anything in Blender to use as a value to adjust another value. You can adjust any value with any other value. And you can choose different kinds of types to use as your driver value. So we have curves and we have values that we can adjust. So again, if we go back to the definition of a driver, it might make more sense now. So at the beginning I said drivers can use properties, numbers, transformations, and scripts to control the values of properties. Hopefully that makes a lot more sense now. For more details, watch some more tutorials or go to the Blender documentation for drivers. It's under animation / basics / drivers. So hopefully that helped you learn the basics of drivers, and hopefully you have a simple understanding of them now. I know I'm not an expert. I don't use them all the time. But I do know the basics of them. So hopefully I didn't mangle this up too bad, and I hope you guys learned enough that you can now go creating your own drivers, play around with it a bunch, see what kind of cool stuff you can create. If you create something really cool, definitely share it with me so I can check it out. But anyways, thanks for watching from the team here at BlenderTech.com. And if you enjoyed this video and learned something, please like it and don't forget to subscribe for more videos. We're now on Twitter at twitter.com/blender_tech and Facebook at facebook.com/BlenderTech page, all one word. If you dislike this video for some reason, don't just hit the thumbs down button and leave. Instead, please leave a comment, or if it's private, email us at info@blendertech.com about what you did not like and why. That way we can continually improve our videos based on community input. That was the core that we wanted the core value that we wanted when we started Blender Tech. We also take requests for help and tutorials. So if you're having an issue with something, or if there's something you'd like to see, just give us a shout. We'll definitely try to solve it for you. So see you next time, and remember, create your way.